Okay, guys, we are talking about rationalizing radicals today. We are still on learning target 1. To be in simplest form, there should not be a radical in the denominator, okay? We are going to simplify the expressions. We don't want any decimals, so we're going to talk about how we can deal with a radical in the denominator in the first steps we need to take. So with example 1, I have the fourth root of 162 divided by the fourth root of 2. So obviously they're both even numbers. So I can do 162 divided by 2 to give me the fourth root of 81. Okay. And then you need to simplify it from there. So if I took 81 and I broke 81 down, I get 9 and 9, which breaks down into 3 and 3. Okay. I'm looking for a group of 4 because it is a fourth root. It's a group of 4 right there. So that tells me 81 is a perfect fourth root of 3. So 3 would be your answer. All right, example 2. I have the square root of 18, x to the 5th, divided by the square root of 2x to the 3rd. So now we have some variables. Let's first do 18 divided by 2 to give us the square root of 9. When you have variables, okay, imagine it like this. I have 5 x's on the top, and I have 3 on the bottom. Well, how many can I cancel out? 1, 2, 3. How many do I have left, and where are they at? Are they on the top or on the bottom? So I have 2 x's left on the top, so I would leave them up top with my 9. Okay, I don't have anything left in the denominator. My numbers divided evenly, so now I have the square root of 9x squared. The square root of 9 is 3. It's a perfect square. How many groups of 2 are in x squared? Well, just 1. So my answer becomes 3x. Looking at example 3 now, I have the cube root, okay? When it looks like this, that it's the same thing as if it were written like the cube root of 162y to the 5th over the cube root of 3y squared, okay? Same thing, they just wrote it a little differently, which is totally okay. Okay, so now let's do 162 divided by 3 to give us 54. Okay, I have y to the 5th on top and y squared on the bottom, so I would have 3 y's left up top. Okay, again, if you need to write them out, please do so. So 5 up top, 2 on the bottom, 2 cancel out, and I have 3 left on the top. So now we're going to simplify the cube root of 54, which breaks down into, take it over here, 9 and 6. 6 breaks down into 3 and 2. And 9 breaks down into 3 and 3. So I'm looking for a group of 3 because it is the cube root, and I have a group of 3 right here. I do have one little leftover 2 that will need to stay on the inside, okay? So it would become 3 cube root of 2. Now looking at my variables, I have y cubed here. Well, how many groups of 3 are in y cubed? There's just 1, so I'm pulling out 1y, so 3y. Cube root of 2 is your answer. All right, example 4. So this one's a little different now, okay? I'm going to write it out as the square root of 2 over the square root of 3, okay? Obviously, I can't do 2 divided by 3. That doesn't simplify in any way. So when you have something like this, you need to multiply by what's in the denominator, okay? So I'm going to multiply this by the square root of 3, and I also need to multiply the top by the square root of 3. So square root of 3 times square root of 3 would give me the square root of 9 over the square root of 6. Remember, multiplying radicals just like we did in the last learning target. And this is where we're going to need to simplify. So can I simplify the square root of 9? Well, 9 is a perfect square, so it would turn into 3. Can I simplify the square root of 6? No, because it just breaks down into 3 and 2, and there's no pairs in there, so I would leave it as the square root of 6. So your final answer is the square root of 6 over 3. Okay? Same kind of thing, example 5, I have the square root of 3 over the square root of 5, so I'm multiplying my numerator and denominator by the square root of 5. Okay, so I would get the square root of 15 on top and the square root of 25 on the bottom. The square root of 25 is 5. And I cannot break down the square root of 15 because the only thing to multiply to give me 15 is 5 and 3. So it stays as the square root of 15 over 5. All right, I have 1 over the square root of 2. So now we're doing the same thing, multiplying the top and the bottom by the square root of 2 to give me square root of 2 over square root of 4. Well, the square root of 4 is 2. The square root of 2 can't be simplified either, so that is as far as we can go. All right, example 7. I have 2 over 3 square root of 6. So just like in the last couple, we're actually going to multiply by the numerator and denominator by the square root of 6. We're doing this because we can never have a square root in the denominator like we talked about before. So when I do this, this would become 2 square root of 6, okay? Remember, it has to be a radical for me to be able to multiply them. If not, I'm just going to be multiplying that 2 by the 1 in front. The denominator will become 3 square root of 36. So 2 square root of 6, square root of 6 does not simplify, so I'm going to leave it as the square root of 6. 36 will simplify. 36 is a perfect square of 6, so I would do 6 times 3 to give me 18. Okay, so now you need to pay attention to your fraction. I have 2 divided by 18 now. Okay, I need to simplify that as well. So 2 divided by 18 will reduce to 1 over 9. Okay, don't forget your radical 6 either, and that would be your final answer, 1 radical 6 over 9, or you can also write it as radical 6 over 9, okay? Same thing. They're both correct answers, okay? All right, example 8. Now I have 3 over the cube root of 4. So I have to do is I'm going to break down my 4, okay? So I'm going to break down into 3. I'm breaking it down to 2 and 2 like I just did the factor tree. I'm just leaving it written underneath the radical. I need to find something to multiply by these 2 numbers that will get me a cube root. So it's a cube root, so I need 3 numbers that are the same. So I would multiply the denominator by the cube root of 2. And I also need to multiply the numerator by the cube root of 2. Because if I did 2 times 2 times 2, well, that's a group of 3 that I could pull out, okay? So you could just go ahead and pull that 2 out and leave that as your denominator. And if I multiplied the top, I would get 3 cube root of 2. And that would be your final answer, okay? So you're finding something in the denominator, okay? You're going to do your factor tree and leave it under the radical, and then see what number I need to make it a perfect cube, all right? All right, same kind of thing for example 9. So this one is a little different. I have 2 over the cube root of 3. So how many more 3's do I need to make it a perfect cube? Well, I need 2 in this case. So if I need 2, more than one number, I need to multiply those together. So 3 times 3 would give me 9. So I would be multiplying this by the cube root of 9. Okay? Because then that 3 is my cube root that I'm pulling out. Okay? So I'm going to multiply the top first. I'm going to get 2 cube root of 9. Okay, since you can already see that I'm pulling out that my cube root is the 3's, you can leave it as the 3's, okay? If you need to multiply it all the way through, so it would become 3 cube root of 27, and then simplify it to 9 and 3 and 3 and 3 to get your group of 3 there that you're pulling out, that's fine. But just know that you can take a shortcut, whatever you're making it the cube root of, that's the number that you're going to have in your denominator. So 2 cube root of 9 over 3 would be your final answer. Okay. If you have any questions, guys, please let me know. Otherwise, have a great day and get started on your assignment.